talks about inequalities and absolute values. Now, the first thing we will start out with is section 9.1, which talks about set operations and compound inequalities. Now, the first thing that I want to start about is sort of like a little bit of a review. And in this one, I want to talk about how to find the intersection of two sets. And this will help us when we start solving the inequalities and absolute values. We will use this information of the intersection of sets. So let's say, let's look at our definition first. Okay, so when you are taking the intersection of two sets, and to represent the intersection, we use the symbol A intersect B. That's sort of like an upside down U. It's defined as and we're using set notation here, so we're saying when you have the intersection of two sets, it's the elements X, and X is defined as an element of set A, and X is an element of set B. So the idea is it has to be a part of both our sets here to be included in the intersection. So it cannot be in one set and be in the other one. It has to be in both at the same time to be included in the intersection. To look at it in terms of a diagram, which we call as a Venn diagram, if you have these two sets, this is your set A and this is your set B. So the idea is the intersection will be formed by only those elements which are common between our two sets here. Okay? So to understand this intersection idea better, let's look at an example here. Let's say we have our set A, which has elements 1, 2, 3, 4, 5, and 6. Okay. We have a set B, which has elements 1, 3, and 5. Let's say we have another set here, C, which has only 1 and 6 in it, and a set D with just one element, 4. Okay, so these are our sets here, A, B, C, and D. Now let's look at what is B intersect A. So we're just trying to find different intersections here. A intersect B, A intersected with D, let's see, B intersected with C, and the last one, A intersects with C. So we're just taking two different sets here and trying to find their intersections. So again, as I said, when you're finding the intersect of two sets, only those elements will be part of your intersection, which are in both your sets. So we're looking at B intersected with A. B has the elements 1, 3, and 5. And let's see, A has 1, 3, and 5 as well. So the intersection will have 1, 3, and 5 as our intersected elements. The next example is where we're intersecting A with B. So A, of course, has 1, 2, 3, 4, 5, 6. But since B has only 1, 3, and 5, only those will be the three common elements. And your intersection here is 1, 3, 5, which is similar to what we had with B intersected with A. Okay. The next one says intersecting A and D. So we're looking at the set A here, and it's being intersected with set D. Now, D has only one element, 4, and set A, of course, has the element 4 in it, so your intersection will just have that one common element. So as you can see, we are not including any of the elements that are not common to both our sets here. If it's in one set but not in the other, then it does not go under your intersection. Now let's look at B intersected with C. B has the elements 1, 3, 5. C has 1 and 6. So the only element common between the two sets is the element or the number 1. So you will include only that. The last one here is A intersected with C. A intersected with C. C has 1 and 6, and those are also part of A. So we can go ahead and say that the intersect of the two sets, A and C, will be the elements 1 and the element 6. Now what if, let's say we had another intersection here. Let's say we had the intersection of the set B with the set D. Okay, B and D, which is our two sets right over here. B has the elements 1, 3, 5, and D has the element 4. Now as you can see, there's nothing common between our two sets here. So that tells me the intersection of B and D is going to be an empty set or a null set. So when you're talking about an empty set, you just use your brackets here, but you don't put any element in there. And that tells me this is an empty set. Or sometimes you will see this symbol being used for an empty set, where you just have a 0 with a line going across it, and both of these represent empty or null set. Okay? So anytime you come across a situation where there's nothing common between them, you'll call it an empty set. All right. Now, that was our discussion on intersection of sets. Let's talk about how this is going to be useful to us. Now, as I said, we were going to use this information in our inequalities. So let's go ahead and talk about what a compound inequality is. Basically, we're saying a compound inequality consists of two inequalities joined by connective words and or. Now remember, an inequality is basically where you take an algebraic expression and instead of using the equal to symbol, you will use the greater than, less than, or the greater than equal to, less than equal to symbol. So if you take two of those inequalities and join them by using the words and or, that becomes a compound inequality. You can think of your, for an example, you have this compound inequality, let's say, and you can see we're using the word and to join those. If you had another compound inequality, let's say of this form, we could use the word or to join them together. And both of these are just examples of what your compound inequalities will look like. Right, now let's talk about how to solve a compound inequality that has the word and in it. Okay, now the first thing you would do is you would solve each compound inequality individually, and then since we are using the word and to join the two compound inequalities, the solution set will include all the numbers that will satisfy both our inequalities that we solve as the first part. So let's look at an example here to see how exactly will we work with this. So you have x plus 5 is less than or equal to 11, and x minus 3 is greater than or equal to negative 1. Okay? So as I said, let's go ahead and solve each one of them here. X plus 5 is less than or equal to 11. We will get our x by itself, so move your 5 over, and you get x is less than or equal to 6, as you can see right here. And on the other side, now we can solve this guy here, and we'll again want to move our 3 over, get x by itself, and you end up with x is greater than or equal to 2. So you can see we have two different solutions here, and we're using the word and to join them together. Now, this is where your intersection of sets will come into play. Now, if I was trying to graph this equation here, you have your 6 here, and you can see this says x is all the values of 6 and anything less than 6. So we are including 6 in our answer, and all the values that are less than 6 will satisfy this half. For the other half, we are saying x is greater than 2 and equal to 2. So if this is 2 here, we're including 2, and then all the values greater than 2. So to find a solution to our compound inequality, we have to take the intersection of both these sets. So let's go ahead and try and put this together on the same graph. Now we're saying for our one side of our inequality that x is less than or equal to 6. So equal to 6, of course, and then everything less than 6, which will be right here. And the other half says x is greater than or equal to 2. So x is greater than or equal to 2, so we know all of these values. So when we take the intersection of these two sets here to solve our compound inequality right over here, this will be your solution. The values of x have to be between 2 and 6, because x can be greater than 2 or equal to 2, and x has to be less than or equal to 6. So right here, x is including 2, greater than 2, and including 6, less than 6. So your solution set for our compound inequality with the word and is going to be this interval from 2 to 6, anything in between 2 and 6, and the brackets tell us including the numbers 2 and 6 itself also. And that's how you solve a compound inequality with the word and. Let's look at another example and let's see if you can come up with a solution with this. So we're looking at an example, negative 3x less than 3 and x plus 2 less than 6. So again, you start by solving each inequality individually. Now we want to get x by itself, so we divide both sides by negative 3. Now remember, when you're working with inequalities, anytime you multiply or divide by a negative number, this sign here will change. This sign changes anytime you multiply with or divide by a negative number. So your inequality symbol will flip. Instead of less than, it now becomes greater than, and you have x is greater than negative 1. Okay, so we solve that half. Now here, we want to get x by itself, so we subtract 2 on both sides. Subtraction and addition will not change the inequality symbol, so don't change anything here. You will end up with x is less than 4. So now we have our two sets here. Again, we're saying x is greater than negative 1. Now you will notice we are not including negative 1. This is a strictly greater than symbol, so that tells me x is only greater than negative 1 but not including negative 1. Same thing on the other side, we're saying x is less than 4 but not including 4. So we will use parentheses to show that. So when I combine both of these solutions together, I get negative 1 and 4. X is greater than negative 1 and x is less than 4, not including negative 1 and 4. So when you write your solution set, you will write it as negative 1 and 4 and use parentheses. This time you will notice we do not use brackets because we don't want to include negative 1 and 4 in our answers. And there you have it. That's how you would work with